Hey guys, welcome to question FM248 of the Further Maths Fortify study guide. This question reads, a school that trains massage therapists holds assessments each month to determine the ability level of each of its students. After each assessment, students are classified as beginner, intermediate, advanced, or graduated. Let matrix T1 be the transition matrix for this model. Matrix T1 is shown below and contains the percentages of students who are expected to move between ability levels or graduate. And then we're given this transition matrix here. Question A says an incomplete transition diagram for matrix T1 is shown below. Complete the transition diagram by adding the missing information. So our first little assessment we can do here, if we look at this transition matrix, we can see that where we should have information is in 1, 2, 3, 4, 5, 6, 7, 8 different edges. And here in this diagram, we've only got 1, 2, 3, 4, 5, 6, 7. So we're looking for only one transition or one new edge to be added to our diagram. And if you sort of go through each of these, you'll notice that the connection between B and A is missing, and we're looking to go from B to A. So putting in an edge here or even underneath, as long as they connect B and A together, we want our arrow to be making sure, because we're going from before B to after A, we're going from B to A. So this arrow should point towards A, and just showing the 10% there, jotting that in will complete the question. We're then given some more information before question B. And that information says the number of students at each level immediately before the first assessment is shown in matrix S0 below. And we're given this initial state matrix. Matrix T1 contains the percentage of students who are expected to change their ability level or graduate after each assessment. Question B asks us, what percentage of students are expected to move into the advanced ability level after the first assessment correct to the nearest whole percentage? So in order to figure this out, we're going to create a fraction. And on the bottom of our fraction is going to be the total that we're looking at. So we're looking for a percentage of students. Now the total amount of students that we have at the moment in this school is going to be 100 plus 60 plus 20. According to this state matrix, we've got 100 beginners, 60 intermediate students, and 20 advanced students. So that's the beginning of our fraction there. Now we also want to find what percentage of all the students are expected to move into the advanced ability level after their first assessment. So looking at this, we can see that we are expecting 10% of our beginners to move into the advanced. So 0.1 times, and the number of beginners we have is 100. So 10% of our beginners, so 10% of that 100 should move in. And we should also be expecting 65% of our intermediate students to move to the advanced. So 0.65 times 60. We don't include the students going from advanced to advanced or staying in advanced because they're not technically moving into the advanced group, they were already there. So this sets up our fraction. Of course, we're going to times the whole thing by 100 in order to convert to a percentage, which should give you an answer of 27.22 recurring, which you would round to 27% to give your final answer there. Cool. We're then given question C. Question C says, how many intermediate level students are expected to be in the school after 2 assessments? Write your answer correct to the nearest whole number. So here we're looking for S2 because we're looking for after 2 assessments. Now S0 is before any assessments has occurred. So S1 would be after 1 assessment, means that S2 is after 2 assessments. Now this question is made a little bit easier because we're not having to add matrices, we're just multiplying transition matrices with state matrices, so we can actually take this transformation matrix and take it to the power of 2 times that by our S0 and we'll get a value of S2, rather than just timesing it by the transition matrix once. We times it by the transition matrix twice to take us to the second state instead of the first state. So taking this transition matrix, putting it into a calculator and squaring it, and then multiplying that by this state matrix should give you a matrix that looks like this as an answer. So 4, 46, 94, and 36 when rounded, and we are looking for the number of intermediate level students, which means that we have 46 intermediate after 2 assessments. Question D now goes on to ask us, after how many assessments is the number of students in the school first expected to drop below 100? Now, just to bring S2 back for a moment here, actually. We had 4, 46, 94, and 36. We can already see, now the only number that we're not going to include from this when we're creating our tally of students is the 36, or this lowest number in each of the cases following, because these students have graduated. So we're not going to include them as being in the school. But you can see quite clearly here that 94 plus 46 plus 4 is definitely going to be well over 100. So it's not after 2 assessments. We can go to the third assessment. After the third assessment. So in order to calculate this, once again, we can take our transition matrix, this time taking it to the power of 3 and timesing it by our initial state matrix. Putting this into a calculator should give you a matrix that looks like this: 1, 19, 82, and 78. When we add these first 3 numbers together, we've got 1 plus 19 plus 82. Adding all of those together should land us at an answer of 102 students. So we are still over the 100, but we're fairly close. So it'd be a pretty safe bet to see if, be a pretty safe bet to say the next one will put us under 100, but of course we still want to make doubly sure. So S4 is going to be our transition matrix to the power of 4 times our initial state matrix. Once again, putting this into a calculator, we should end up with an answer of, now these answers I'm putting in are all rounded, by the way, to the nearest whole number, just so they're easier to write down, but they should work the same way regardless. So now we've got 0 plus 7 plus 57, which is equal to 64. So we can see that before the 4th assessment, we had over 100 students. After the 4th assessments, we have well under 100 students. So in answer to question D, after how many assessments is the number of students in the school first expected to drop below 100, the answer would be 4 assessments. Excellent. Now we're given a little bit more information before being asked to answer the final question, or the final part of this question. So we're told that another model for the number of students in the school after each assessment takes into account the number of students who are expected to join the school after each assessment. Let Sn be the state matrix that contains the number of students in the school immediately after n assessments. Let J be the matrix that contains the number of students who join the school after each assessment. Matrix J is shown below, and then we're given this matrix down here. The expected number of students in the school after n assessments can be determined using the matrix equation Sn plus 1 is equal to T1 times Sn plus J. Question E, and then below that we're told once again that S0 is this initial state matrix that we were given at the beginning. Question E says, consider the advanced level students expected to be in the school after 2 assessments. How many are expected to graduate after the next assessment? Write your answer to correct to the nearest whole number. Now here we've got to go through a slightly different process. We have to first calculate S1 according to this new rule, which is going to look like this. And we can't immediately jump to S2. The reason being that we're adding this matrix J. Now, I won't go into too much detail here, but if you're wondering about it and want to ask any questions, please go ahead. But because of this plussing matrix J, we can't just square the transition matrix and all will work out and we can jump straight to S2. We actually have to go through this recurrence relation one by one. So plugging that all into a calculator, so our transition matrix times our initial state matrix plus J will give us an answer of 40, 101, 65, and 9. From here, we now need to calculate S2 because we want to know, we have to start with the number of advanced level students expected to be in the school after 2 assessments. So S2 is going to be equal to T1 times S1 plus J. So of course, taking this first transition matrix as normal, S1 is now this matrix that we calculated just before, and J is going to be this new one. Sorry, this new one that was introduced, adding on to the end. Plugging that all into your calculator, you should get an answer of 28, 73. Once again, guys, I'm rounding here, 110 and 38. From here, we have 110 advanced level students, and the amount that we are expecting to graduate after the next assessment. Well, according to this transition matrix, we're expecting 45% of our advanced level students to graduate. So we take that 100, I'm just going to take that 110, times that by 0.45, which should equal, when rounded and corrected, that should be equal to roughly 50 students. So we're expecting 50 of our advanced level students to graduate after the second assessment. Guys, that's all the questions for FM248. If you have any questions for us, please drop them in the comments below. Otherwise, I will see you in the next video.